Welcome to my channel, dear students and all the viewers. See, here is a very important problem, and that is the differentiation of the greatest integer function. Okay, and that is first function is here y equal to box x and y equal to box of twice x minus 1. And this is a very important video for today. Okay, so now first I want to introduce what is the greatest integer function about that. So see, this is a box function or floor function. It can be written as like that, and this is almost the same here. If for box x, if we put here integer like 2, so then you got here 2. If we put here minus 2, then we got here minus 2. If we put here 5.99, and this is the integer part is here 5. So if we have 5.001, so it will be also 5. So it means in the case of it is the greatest integer function, so addition for this part, so the for example the fraction part would be neglected. This is here addition fraction part would be neglected. In case of this is 4.9, so it would be here minus 5, not approximate value, it would be here minus 5. So I'll give more example, that is if it minus 4.1, it would be here minus 5 also. So how it possible? See here, it can be written as like minus 4, and this is minus 0.1. I'm saying that the addition fraction part would be neglected. So for that, here is a subtraction. So we want to get here addition. So it can be written as like minus 5 and then 1 minus 0.1. So it will be here minus 5 plus 0.9. So then we got minus 5. So I think the basic conception of the greatest integer function, it's clear. So after that, I want to draw the diagram for the greatest integer function. Okay, see, so draw the curve for this. You take the function y equal to box x. So first draw, and this is as a y-axis and this is as a x-axis. Okay, so for the curve y equal to x, this is the pattern of like y. If y equal to x is this, so if 1, take here 2, this is 3, this is 4, and this is 5 here. Again, this is here minus 1, minus 2, minus 3, minus 4, this is 1, this is 2, 3, and 4, this is minus 1, minus 2, minus 3, minus 4, like that. For that, okay, if we take x and this is our box x, if we take 0, then we got 0. If we take 0.1, so this is box 0.1, so it would be a 0. 0.7, and then it would be also 0. 0.9, then again 0. 0.999, then it would be 0. So the drawing is here. Okay, for this case the drawing is here. Not exactly 1, so this is less than 1. Okay, this is not equal to 1. Okay, we take here 0.99 something, then it would be here 0. If we take 1, then we got here 1. So this is the for this case. Again, if we take here, this is 1, then we got here 1, 1.1, then again 1, 1.5, then again 1, 1.9, then again 1, 1.999, then again 1. So the drawing is here, the value of y here is 1, so the value of here is from 1.1 to 1.99 something, then the value of y is 1. Okay, okay. Again, if we take here x and box x, see, this is 2, 2, 2.1, then again 2, 2.5, then again 2, 2.999 something, then we got here 2. Okay, so the value of y here is 2, so this is 2, so from that exactly 2, so touch the point 2 here, but this is okay, this is here parallel to 2, and up to the point here close to 3, not equal to 3, so that's why. Okay, so again if we take 3 point something, and then we got the value 3 of the box function, 3 point something to 3.99 something. Okay, not exactly 4 up to, this is 3.99 something. Okay, in the case of negative, and this is your box x, see, this is negative, this is minus 0.1, box of minus 0.1, this is minus 1. Okay, again minus 0.5, minus 0.5, minus 1, minus 0.99 something, this is minus 1, minus 1, then it will be here minus 1. Okay, minus 0.000 something, then it is 1. So it is, see, this is exactly 1. So up to 1 for x, this is not exactly okay. In case of more negative, that is x and box x, if we take here, this is minus 1, minus 1.1, so this is minus 2, minus 1.9, this is minus 2, minus 1.99 something, then again it is minus 2. Okay, for the case of minus 2, see the drawing here, Okay, and this is exactly, we got the value that is -2, and taken from -2, exactly -2, up to -1.0001, so it would be here -2. So this is not exactly up to, okay, close to -1, not exactly -1. Okay, so this is the drawing of the box function. See, it is differentiable. See here, from this to this, from this to this, from this to this, and it is the fraction. It is the fraction. So when the value of x is fraction, then the function and this box function is differentiable. So when the value of x is fraction, then the function is differentiable. See, this is a tangent of this curve are parallel to the x-axis, parallel to the x-axis. You know, the derivative of x-axis is 0. So the derivative of these is all are 0, which is parallel to the x-axis. So it is differentiable of this function when x is fraction. Okay, differentiable, and the value of the derivative is 0 for this function. But see, when it is an integer, so in that case there is a gap. So therefore this is not a differentiable when it is an integer. Okay, so now I am showing with the help of derivative. So see, f of x is equal to, this is box x, so therefore the f of x plus h is equal to box of x plus h. Okay, this is box of x plus h. Now from we solve this problem of the derivative of this function with the help of the first principle. You know, the derivative of the first principle is here, f dash x is equal to the limit h tends to 0. So f of x plus h minus f of x over h. Okay, so now the left hand derivative when x is a fraction, when x is a fraction, then left hand f dash x, and that is limit h tends to 0 minus f of x plus h minus f of x over h. You know, this is limit h tends to 0 minus, and this is box of x plus h minus box x over h. Okay, see, for this function when it is a fraction, let us assume then it would be okay, and this is a fraction. So for example, let us assume x is equal to 2.57. Okay, so h has 0 minus, so box of 2.57 plus h, and this has a minus, so this is a very small number, like minus 0.00000111 something. So then we got here approximately 2 point something, so it will be here 2. So the with the help of the greatest integer constant 2 point something, it would be give us as a 2. So therefore the box 2 here is 2. So simply we can say is that x tends to 0, that is 0 over h equal to 0. Okay, and the right hand side, right hand derivative, not right hand side, I am wrongly said, and this is limit h tends to 0 plus the box of x plus h minus box x of our h. So what would be the value of that? So same as if we take as for example 2.75 and plus h minus 2.71. For example, I am showing the what is the value of that. Okay, so it is 0 plus something, same as with the addition of 0 plus 2.75 plus h, so it would be give us 2.7 something. So 2.7 something of this function is here, only 2 here, and also the 2.75 is 2, so it also gives us a 0. So therefore the limit h tends to 0 plus 0 over 0 and equal to 0, as left hand f dash x and is equal to right hand f dash x. So therefore the derivative of box x is 0 when x is fraction. So okay, so derivative is exist here when x is fraction. So okay, now for integer, when x is an integer, when x is an integer, then the left hand f dash x is equal to limit h tends to 0 plus and box of x plus h minus box x and over h. Okay, so this is an integer, you know. So if box is equal to x, then sorry, this is left hand, so this is moving minus. So as this is less than 0, so negative, so it is give us negative. So if box x is x, as x is an integer, so box is as x, so then the value of this expression would be here x minus 1 over h. So that is equal to, this is limit h tends to 0 minus, so minus 1 over h equal to infinity. Okay, minus 1 over h is equal to infinity. For example, how it possible look like x minus 1 minus x, when if we take here x as a 2.75, for example, I want to give you some idea that is 2.75. Okay, no, this is an integer, sorry, I am not taking here, I am saying that this is an integer, so it is, let us assume this is 3, so 3 plus h minus box 3, so as and then and h tends to 0 minus, so it is subtracted from 3, so this is an integer, so this is 3 minus something point something, so it would be a 2 point something, so give us a here 2, so it is a minus 1. So actually from 2 we can write here like 3 minus 1 minus 3. Okay, so that's why I'm writing here x minus 1 minus x, so this is here minus 1. Okay, so this is the left hand derivative. Now I'm showing the right hand derivative, and this is a limit h tends to over h, same as, okay, this is an integer, this is an integer, so this if is a 2, so 2 is here, so that is like x, so this is x plus h, so plus something, so it is an x also, by h. For example, if x2 here, so 2 plus h means 2 and box is 2, so 2 minus 2 is 0 here. Therefore, the left hand f dash x not equal to right hand f dash x when x is an integer. Therefore, the derivative does not exist when x is an integer. Okay, so this is the concept of derivative for the function of box x. Okay, so I think all you are understood for this function. Now I am showing this function, the derivative of box of twice x minus 1. So see carefully. For the function, this when 2x minus 1, we want to get integer. So if this is 0, so therefore we got an integer, then x is equal to half, and that is 0.5. When twice x minus 1 equal to 1, then x is equal to 1. When twice x minus 1 is equal to 2, then x is equal to 3 by 2, this is 1.5. When twice x minus 1 equal to 3, then x is equal to 4. When twice x minus 1 equal to minus 1, then x is equal to 0. When twice x minus 1 equal to minus 2, then x equal to minus 0.5. Twice x minus equal to minus 3, then x is equal to minus 1. And twice x minus equal to minus 4, then x is equal to minus 3, this is minus 1.5. Okay, now first draw the curve. Actually, the value of x look like from 0 here, this is 0, then we got 0.5, this is 1, this is 2. Okay, sorry, this is 1.5, this is 2, this is 2.5, same as minus 0.5, minus 1, minus 1.5, like that. Okay, now I want to plot the straight line. If twice x minus 1 is this, so y minus twice x is equal to minus 1, so 1 over minus 1 and plus x by half, and this is equal to 1. You know, if this is a half and y we have 1, so this is 0.5 and this is 0.5 minus point, okay, this is 1. Okay, so therefore the Okay. If see, if x is here and this is box twice x minus 1, if 0, then this is minus 1. If it is 0.1, so therefore the 0.2 minus 1, so this is minus 0.8, so it is minus 1. If 0.2, therefore it is 0.4 minus 1, then again minus 1, up to 0.5, not exactly 5. If we take 4, 0.4, so this is here 4 2 are 8, 0.8 minus 1, it is minus 1. If we take here 0.499 something, then see what happened here. So see, again it is minus 1. Okay, so draw the curve from, we got here minus 1. Okay, okay. See, this is here 0 to up to close to 0.5, not exactly 0.5 of x. Okay, this is here minus 2, this is here minus 1, sorry, this is here minus 1. Okay, so if we take 0.5, then we got minus 2. If we take minus 0.4, then we got again minus 2. If we take minus 0.3, then we get minus 2. If we take minus 0.1, then we get minus 2. If we take 0.001, then we get minus 2. So for that, this is the value of x which is lies between this is here minus 2. Okay, the line of y, this is minus 2, but the value of x not equal to 0. This is minus 0 point something 1, not equal to 0. So don't touch this line. So it is, but touch this line here, we get here 0.5. So from 0.5 to that, we got here minus 2. Okay, for this is minus 3, same drawing. Okay, x and box twice x minus 1. If we take 0.5, then we got 0. If we take 0.55, then again we got 0. Okay, up to 0.999 something. So this is here 0. Okay, 0.52. This is 0.521, not exactly 1. So that's why. Okay, this is not exactly 1. Same as this is 1, minus 2, minus 3. 1, 2. Okay. So this is the drawing of the function. This is the drawing for the function y is equal to box of twice x minus 1. See, for this function, and this line all are parallel to the x-axis, so this is dy by dx at 0 when the value of x lies between these to these, this to these, this to these. Okay, so okay, but exactly when 0.51, 0.1, 1.52, then this is at that point not differentiable. Okay, only this interval, for this interval and this interval, and for the drawing C, in that case is differentiable. Okay, so I'm showing the mathematical calculation. So this is a drawing. Graphically I'm showing where the function is differentiable for this. Now let's see, f of x is equal to twice x minus 1. So f of x plus h is equal to twice x plus twice h minus 1. Okay, so the f dash x is equal to the limit h tends to 0, and this is box of twice x plus twice h minus 1 minus box of twice x minus 1 over h. Okay, when twice x minus 1 is a fraction, then let us assume the fraction value is a f. So twice x is equal to f plus 1 over 2. This is a fraction, but not 0.5. This is the multiple of, not possible to multiple of 0.5. So okay, so but when x not equal to actually 0.5, not equal to 1, not equal to 1.5, not equal to 2, okay, not equal to 2.5. For that, left hand derivative f dash x, and that is equal to limit h tends to 0 minus c. For example, if we take like x equal to 2.75, this is not equal to the multiple of 0.5. Okay, 0.5, any of the number, this is a fraction. I'm saying that this x is a fraction, but never be of this type of number, and these number are in AP. series. So that type of number not to be taken here. So if we take 2.75, see what happened here. This is the multiple of 2.75. This is 0, 7 to the 14, 15, okay, 0.1, carry 1, 2 to the 4, 5, okay. Okay, plus twice h, this is minus 1, so plus twice h minus 1, and this is again 5.5 minus 1, that is equal to c 4.5 plus twice h minus 4.5. See, here is the h, here h tends to 0 across to minus 1, so therefore as this is twice h, a multiple of the nearest value is 0, so this is the negative value, so this value is subtracted from 4.5 and not less than the 4, so it would be here 4. Actually this is the integer part is here 4, again this is a 4, so this is actually 0, so therefore the 0 over h, so this is equal to 0. So the right hand f dash x, and that is equal to limit h tends to 0 plus c. Again if we take like that number, see what happened here. So this is actually twice x, actually this is here 4.5 plus twice h minus 4.5, for example. Here h tends to 0 plus, so this is a 0 more, so nearest value to 0, so it would be here also 4.5, so it would be here 4 only, same as this is 4 only, so this is a 0. Okay, so therefore 0 over h equal to 0. Therefore in that case the derivative of box twice x minus 1 is differentiable when twice x minus 1 is a fraction and x equal to fraction, but x never be 0.5. This is dot 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 minus 1 minus 0.5 never be 0, never be 0.5, never be 1, never be 1.5 dot dot dot, and this series are in AP series. This type of number can't be acceptable for the differentiation. Okay, it is differentiable without, and these are all the values. Okay, but when x is equal to minus 0.5 comma minus 1 comma 0.5 comma 0 comma 0.5 comma 1, then see what happen. If we take one value like x is equal to 0.5, then box twice x plus twice h minus 1 minus twice x minus 1, see what happened here. Okay, so it would be here 1 plus twice h minus 1 minus actually 0.5. So 1 minus 1 is 0 here. So this is only twice h minus 0, but h approach to okay. So when h approach to 0 minus, so this is a negative value, point something negative, so it will be here minus 1. Therefore the f dash x, then left hand f dash x, this is equal to limit h tends to 0 minus box of twice x plus twice h minus 1 minus twice x minus 1 over h. So this is actually limit h tends to 0 minus 1 over h. So this is here infinity. But right hand f dash x is equal to limit h tends to 0 plus box twice x plus twice h minus 1 over twice x minus 1 over h. This is plus. In that case, so if we take single value like x is equal to 0.5, then for example I'm giving the example, if we take x is equal to 0.5, then see what happened here. So this is here multiple of 0.5, this is here 1 plus twice h minus 1 minus actually 0. So this is actually box twice h minus box 0. So this is twice h, as h tends to 0 plus, so twice h tends to this is point figure, this is point something, positive point something, so it goes to 0. So therefore the limit h tends to 0 plus, this is the right hand limit, so this is actually got 0 here, so this is 0 by h. So this is limit h tends to 0 plus 0 over h, and that is equal to 0. So left hand, in that case, left hand f dash x not equal to right hand f dash x. So this is not differentiable for this type of number. Okay, thank you for watching my video, everybody. See carefully.